that for any real number x, if x squared is irrational, then x is irrational, right? So let me just write that down. So if and then is that A implies B or P implies Q, whatever. So we're looking to prove that x squared is irrational implies that x is irrational. And this could be done using a proof by contradiction, something like that. But on this occasion, we're going to do a proof by contra-positive. Okay, so the reason for doing this is because we're contra-positive, we're going to end up negating both of these. So this is going to be x is rational, implies that x squared is rational, and the main advantage is that it's a lot easier to define something as rational than to define something as irrational. So that is a massive advantage. So what we are trying to prove, we will prove that if x is rational, then x squared is rational. This is the contra-positive. You could write that out in words as well if you wanted to. I don't think I will, but I would write, if x, we will prove that if x is rational, x squared is rational, then x squared is rational. Right, and if we can prove that the contra-positive is true, and this should be a direct approach, as in we're going to just define x being rational mathematically, and then we're just going to find an expression for x squared and prove that it must be rational when this is true. And once we've proven that the contra-positive is true, that is enough to prove that the original statement was true as well, which is this up here. So we're going to see if x is rational, or as x is rational, a rational number, as x is a rational number, that means x equals p over q for some integer p and q, and the bottom one, q, cannot be 0. Q cannot be 0. Now, for certain types of situation, you would stipulate another condition whereby they don't have any common factors other than 1. But for this particular one, we shouldn't need it. But actually, if you're never not sure, just put it in as well. You're better off having it and not needing it than needing it and not having it. So here is our x, is p over q. So now we suppose that this is definitely true. And then we prove that when this is true, this must also be true. So let's find an expression for x squared. So x squared must be p over q squared, which is p squared over q squared, right? And if you look at that, well, these are both integers. So this is integer, p was an integer, so this is an integer. And q, we said, was an integer, and it's not 0. So this is an integer over a non-zero integer. So this proves that x squared is rational when x is rational. So basically, the contra-positive is true, so the original statement must also be true. The contra-positive is true, therefore, original statement, so that is this bit up here, original statement must also be true. Okay, proof by contra-positive.